width of the paper towel, or the cylinder. So in this case, when we have a cylinder, really the height is just this height here between the centers, and the width is just, or the length is just the circumference. So it's the distance around one of the bases. Right, so it's pretty simple and straightforward to find the lateral surface area of a cylinder, because all you need to do is define the height, which we'll give to you, and then the circumference, which you define by having the radius or the diameter. So lateral surface area is equal to the circumference times the height, or 2 pi RH for the area unit squared. I'm sorry, not just, or unit squared, yes, for the area of a cylinder. Okay, moving on, we're going to talk about total surface area as well. Now remember, we have two congruent parallel bases that are circles in a cylinder. So all we need to do is add the lateral surface area plus 2 times the base area, which is going to be pi r squared. All right, so lateral area plus 2 times the base area gives us 2 pi RH, which is the lateral area, plus 2 times pi r squared. Okay, moving on to our second circular solid. We're going to call it a cone. So we have cylinders and cones. And a cone in this case has just one base, and that base is a circle. So a cylinder had 2 bases, both bases were circles. A cone has one base, that base is a circle. Now the slant height we'll call L is going to be the same thing as a lateral edge. So remember, we had a pyramid that had a lateral edge and a slant height, and those were 2 different values. In this case, with the cone, the slant height and the lateral edge are the same. When we talk about a right circular cone, the altitude is going to be the distance from the vertex to the base of the circle, and in a right circular cone, the altitude and the base are going to be perpendicular to each other. And the altitude is going to meet right at the center of the circle as a base. So we have L, which is our slant height, our altitude here, which is the yellow line, and then the radius here, or the vertical yellow line, and the radius, which is our horizontal yellow line. And let's just draw this in, radius, and that's going to be in a right circular cone. And circular is spelled incorrectly, but that's okay. We'll move on to lateral area. So the lateral area of a cone is going to be 1/2 of the circumference times the slant height, or pi times r times L. All right, so how did we get that? 1/2 the circumference. Circumference is 2 pi r. So 1/2 of 2 pi r gives us pi r. So lateral area of a cone is going to be pi r L. All right. Total area of the cone is going to be the lateral area, pi r L, plus the area of the base, and we just have one area, so it's going to be pi r squared. So lateral area of the cone, pi r L. Total area is going to be pi r L plus pi r squared. All right, the last circular solid we're going to talk about is going to be a sphere. So a sphere now, it's a 3-dimensional figure that is defined by the length of the radius. So remember, a circle was a set of all points in 2 dimensions that were equidistant from a fixed point called the center. With a sphere is a set of all points in 3 dimensions that's equidistant from a fixed point called the center, and that length from that fixed point called the center to the sphere itself is called the radius. So again, a sphere is a 3-dimensional figure that is defined by the length of its radius, just as a 2-dimensional circle is defined by the length of the radius. All points in the sphere are equidistant from the center of the sphere. Now, there's no lateral and total surface area of a sphere. There's just total surface area of the sphere, and that's going to be 4 times pi r squared. So 4 pi r squared is going to be the total surface area of our sphere. All right, now let's get into doing a couple practice problems, and then we'll be done. All right, we've got 3 problems to look at. We're going to find the total surface area of each figure. The first one, we're going to find the total surface area of the cylinder. So remember, we want to find the lateral surface area first, and then we're going to add the area of the bases second to get the total surface area. So the lateral surface area in this case is going to be the circumference times the height. So the circumference is equal to 2 pi r. So 2 pi times the radius, which is 8, times the height of 12, and that's going to give us our answer. So 2 times 8, which is 16, times 12. And I'll have to break out my calculator to figure out what 16 times 12 is, and perhaps you can work along with me. So I have 2 times 8, which is 16, times 12, gives me 192 pi for my lateral surface area. Now my base area is going to be pi r squared. So pi times r squared, which is 64, and then I'm going to multiply that by 2 because I have two bases, so that gives me 128 pi. So if I add 128 pi to 192 pi, I end up with 320 pi as my answer. So 198 pi plus 198 pi, 192 pi, I'm looking at this incorrectly. 192 pi plus 128 pi leaves me with 320 pi. All right, now the cone is going to be pi times the radius times the slant height. So very simple, pi radius slant height, that's a lateral surface area, and that gives me pi times the radius 2 times the slant height of 4 gives me 8 pi. That's the lateral area of the cone. Then I have to add just one base. It's going to be pi r squared. So pi r squared is going to be pi times 2 squared, which is 4. So 4 pi. And so my total surface area is going to be 12 pi. In the last problem, we're going to find the surface area of a sphere. And the formula for the surface area of a sphere is 4 pi r squared. We see that the radius is 9, so that gives us 4 times pi times 9 squared, or 4 pi times 81, or 324 pi. And I really should be writing units squared here, units squared. All right, so surface area of a sphere, 4 pi r squared, 4 pi times the radius squared, 9 is the radius, 9 squared is 81, 4 times 81, 324, 324 pi units squared is our answer for the surface area of a sphere. Well, that's it for Aughton Math. Thanks for joining us. Come back and take a look at some practice problems on the surface area of circular solids in the next edition of Aughton Math.